300 seconds. What is the difference between ARP table
Oh,
and MAC address table? Difference between MAC address and ARP table, ARP table and MAC address table?
MAC address table maintain the MAC.
No. Please explain properly the difference between ARP table and MAC address. You can explain the both. What is ARP table? What is MAC address table?
MAC
Ajay?
address table contain all the MAC address of the device which is connected to the switch. ARP
yes,
table
sir.
user.
Which device is going to maintain ARP table?
Sir, Mac ARP table maintain switches.
ARP table will be maintained by the device where will configure the IP.
IP address plus MAC address. Yes.
Maybe on the PC, routers, right? So whenever you will configure IP address on the Ethernet port, device will start maintaining ARP table. And
Yes.
which device will maintain MAC address table?
Sir, switches.
Switch.
Switches, right?
Yes.
What is the purpose of ARP table?
ARP table purpose of ARP table to get
It resolves the MAC address issues.
To store MAC address information with IP address,
yes.
correct?
Yeah, right.
And what is the purpose of MAC address table?
For communication. Yeah, STP. For TCP connection relay.
No.
To forward the packets on basis of MAC address.
For the layer 2 switching, you can say. For layer 2 switching, ARP table and MAC address table. Sometimes people are thinking both are same. No guys, both are different. Right, so this is your first question and this is again interview question. Okay, so ARP table will be maintained by device where will configure the IP address to store MAC address with IP address, right? As you know, for the basic communication we need source IP, destination IP, source MAC, destination MAC, right? So PC will get destination MAC address in the ARP table only, and MAC address table will be maintained by layer 2 switches to forward traffic at layer 2, like for layer 2 switching you can say, right? Clear? Then what is the use of DTP protocol? DTP?
It is used to negotiate the
trunk
connection.
between the
To form
Sir,
trunking between the switches dynamically, automatically. Correct? Correct guys?
yes, sir.
What is the
Yes.
use of CDP? Yeah.
Cisco discovery
Discovery
protocol.
Okay. And what is the use
to
of
get neighbor
CDP?
information.
Used to find the neighboring devices.
Correct. Connected devices.
Yes, connected device
And
between
which
two
protocol
switches,
we
two
have
devices.
for other vendor devices?
LLDP.
LLDP. Very good.
LLDP.
Very good. And then what is VTP protocol?
Virtual trunking protocol. It
VLAN
is
trunking
used to
protocol.
communicate between
Not
two VLAN.
communicate.
Forwarding
Used to
VLAN
VLAN
data
information,
from
modify the VLAN information in a switch.
VLAN information sent
Yeah,
to
to
between two devices,
centralize the
two switches.
VLAN database.
Yes, sir.
We can say to centralize the VLAN database.
Database.
And how many modes are there?
Three
There
modes
are
are there.
Server,
three
client,
modes.
transparent.
Three modes are there.
Client are
Server,
modes.
client, and
transparent.
transparent.
Very good. And what is the
And
difference
to
between
manage.
each mode?
कैसा?
Difference between each mode? Server mode, client mode, and transparent mode.
In server mode we can delete VLAN, edit VLAN and remove VLAN.
Okay.
But
Create also.
client we cannot.
Transparent mode,
Transparent
mode
we
can
can do
isolate
same thing,
the
but
VTP.
it cannot update in a BTP update. Due to this, it do not negotiate VLAN information.
Okay, and someone
Yeah.
was saying transparent mode.
Yes.
Transparent.
Transparent mode, in mode you can add
It
VLAN
will isolate the
information,
device to take part in the VTP.
and as well as external VLAN we can also create external VLAN.
Okay.
Yes,
And transparent also
and
it work as a relay as well.
yes, sir. But there is one issue: we cannot forward the VLAN information to one switch to another switch
No,
because
we
of
cannot update VLAN database on the transparent
No
mode
one.
because
through
of
VTP message.
Transparent mode,
transparent
it will
mode.
forward the VLAN
Transparent
information to
BTP
another
do not
switches.
generate.
Great, great, great.
Yes.
And what are the requirement of VTP?
Sir, trunking should be enabled and domain name must be matched as well as password is optional.
Yeah, trunking must be there, domain name must be configured and must be same, right? What is MD5?
Password.
MD5 charges value MD5
It's an encryption method.
it is
MD5 is the
It's an
Combination of
authentication.
two
hashing
things.
algorithm.
algorithm. It is the algorithm.
Combination of two things, right? The domain
Mac
name
plus
plus CR number.
domain plus CR number. Yes.
What is CR number?
Configures revision number. If one VLAN is added, then it will increase one. If a VLAN get deleted, then it will increase one.
No, say like this: whenever change will occur in the VLAN database, it will be incremented by 1.
Uh, yes, sir.
Okay. Okay.
Yes.
Then we have another layer 2 protocol, that is STP. So why we come up with STP?
To avoid a layer 2 loops.
Avoiding the
To
loops.
avoid loop.
To avoid layer 2 loop.
Loop.
How STP is going to avoid layer 2 loop?
By detecting the
By
potential
to
loops and
set
preventing the blocking the loops.
By
Based on
blocking the
election.
redundant path. And how it will block the redundant path?
Alternate code.
With
And
the help of election.
yeah.
Election of root bridge, root port, designated port and alternate port. Okay, how many types of topology changes are there in STP?
Sir, there are
3.
three:
Three types
insignificant technology change, and direct
Insignificant,
technology change,
direct and indirect.
and
Very good. How much time STP needs to convert the topology in case of insignificant topology change?
300 seconds.
30 seconds.
That is
Yes, sir.
So, not 300, 30 seconds, okay. And how much time required
Yes,
in
sir.
direct
30 seconds.
topology change?
50 seconds. 20 plus
Very
30.
good. 50 seconds. And again 30 seconds in indirect topology change. How many types of spanning tree protocol we have?
Sir, STP, RSTP,
and
RSTP
PVST,
plus
RPVST, then
MST.
MSTP,
CST, PVST,
MSTP.
Yes,
and PVST
CST,
plus.
PVST, PVST plus, RST,
ST plus
Yes, IMS.
RSTP,
MS.
RPVST, and MST. Very good. Okay. In CST we cannot achieve load balancing. In PVST we can achieve load balancing.
Yes, sir.
Correct. After that we have seen ether channel.
Yes, sir.
So what is ether channel? Why we need ether
Ether,
channel first?
Ether channel is used to aggregate
Utilization of high bandwidth.
logical interface. Or
To combine or to bundle multiple
For
physical
to
link into a
acquire
single logical
conduit.
link. Yes, correct. And how many method we have to configure ether channel?
three methods: SRT, PGP, or LACP.
Very good. In the LACP, we have something called LACP system ID.
Yes.
LACP system IP. What is LACP system IP ID?
System IDs are to negotiate to active port and negotiate with a neighbor.
So, like a switch have, let's say MAC address A. What will be system ID?
A
32768 plus
yes.
A.
A
Priority
MAC
Priority
address.
plus MAC ID.
MAC address, right? And then we have
Yeah,
something
interface
called
ID, sir. Interface ID basically it counted.
port ID. That is LACP port ID.
Yes.
System ID is different and port ID is different. System ID is used
Yes.
to elect main switch, main LACP
Yes, sir.
switch, right?
Yes.
And port ID is used to elect the active ports. Like, you know, we
Yes, sir.
can bundle up to 16 ports. 8 will be in active state, 8 will be in passive state,
Yes, sir.
right? So the ports which will have lower LACP port ID will become active.
Active port.
Okay, so okay, we have already covered these all things. Now let's understand L3 ether channel. L3 ether channel. So guys, see one thing. Let's say for an example, I have here two multi-layer switches. You know, in real time how you are going to use ether channel. See, for an example, I am going to design a network of a small company, a small to medium sized company, right? Let's say any company, XYZ company, XYZ company, and in their data center they have lots of server. In the data center they have lots of servers. So how they will connect their servers? They will connect their servers to access layer switches. You already know this. Yes or no? Later you will also learn why we'll have lots of server. Let's say in the guys Google network, right? Google have lots of application website, right? And they have lots of customer around the globe. So they cannot send traffic of all customer on single server, otherwise server will get choke, because Google is receiving lots of traffic at a time, at a second. So they need lots of server, and there they can distribute the traffic, they can load balance, right? For a specific area we can have multiple servers, and there we will be providing load balancing, right? So let's say here I have some access layer switch, two access layer switch, access layer switch 1 and access layer switch 2. Here also I have two access layer switches, access layer switch 1 and access layer switch 2, right? And for different types of traffic we'll have different types of VLANs to separate different types of traffic connected like this, right? And again here you can see we don't have redundancy between server and access layer switch, so we'll be using multiple link here, right? Like server is connected with multiple access layer switches this way, right? Here also we can connect, so we need two NIC on the server for redundancy. Like this we can connect. For now it's sufficient to connect like this for you guys. But question is how we are going to connect access layer to distribution layer. So access layer to distribution layer, again we are going to use Ethernet cable, right? Here we'll have multiple distribution layer switch. Let's say distribution layer switch 1 and distribution layer switch 2, and I will have two link between distribution layer and each access layer. Let's say here I have two link. So you know HTTP will only allow one link in forwarding state. Here also I have two link. So here also we can configure what? Ether channel. We can configure or not? Yes, we can configure ether channel here this way, right? This way we have connectivity between access layer and distribution layer. So you can see how many ether channel configurations are required here, right? And guys, how we can differentiate two ether channel? We have something called group ID. Remember the last class? We have something called group ID, yes or no? So for an example, this is, I'm going to place these port channel in group number 10, this in port channel 20, this in 30 or 11, 12, 13. Like this we can bundle all the links. So this is how you will be using Ether channel in the real time, or between switches also, but between distribution layer switch we will configure layer 3 Ether channel. Soon I am going to tell you that also. Just give me a minute. Right, so see, lots of Ether channel are configured here this way. Right, now on all the access layer we have some VLANs. Let's say 1 to 100. We have 1 to 100 VLANs on distribution layer switches as well as on access layer switches. And on distribution layer switches you are going to configure what? You are going to configure SVI, right, for inter VLAN routing. Correct, guys?
Yes, sir.
Right, so let's say here we have SVI for all the 100 number of VLANs. D switch 2, D switch 2, right? For an example, for VLAN 1 to VLAN 50, here I have interface VLAN 10 for an example, and here network is 10.1.1.1 or 100 is the IP address, right? IP over here is 100, 10.1.1.100, right? On switch number 2 also I have one SVI, let's say for an example VLAN 50 and 50.1.1.100. This is just an example. Got it? Like this I have lots of SVIs on both distribution layer switches. Now let's say this server is in VLAN 10, right? So gateway IP address of this server is 10.1.1.1 and gateway IP address is 10.1.1.100. They can ping their gateway, and this server is in VLAN 50. This server is in VLAN 50, IP address is 50.1.1.1 and gateway IP address is 50.1.1.100. So now tell me, can this server 1, I am saying S1, communicate with S10 or S50? Server number 50. Can S1 communicate with S50? No, not possible. Why it is not possible? Because when server 1 will generate traffic for server 15, when server 1 will generate traffic for server 15, source IP will be 10.1, destination IP will be 50.1, source MAC will be server 1 MAC address, destination MAC will be the MAC address of destination MAC will be MAC address of, guys, default gateway.
Server 50.
It will forward to access layer switch will forward it to distribution layer switch 1. Distribution layer switch 1 will check layer 2 information, destination MAC will match, then it will check layer 3 information, because destination MAC is the MAC address of distribution layer switch 1. It will check layer 3 information. In layer 3 information it is going to check destination IP address. It will compare destination IP address with routing table. In the routing table there is only one route, that is 10.1.1.0, connected on which interface? Connected on VLAN 10 interface, right? Is route available for 50.1.1.0? No. So distribution layer switch is going to discard it. Now question is, we need to exchange routes, and like this we'll have lots of other SBIs as well. So how to exchange route between distribution layer switch 1 and distribution layer switch 2? Tell me any method that you know. Any method, guys? What you will do?
Routing protocols.
First option is, here I can add one link, and I can make this port as layer 3 link. I can make this link as layer 3 link, and you know, on layer 3 link we can configure IP address L3 link, right? Here for an example I can configure one IP 12.1.1.1, and here I can configure one IP what? 12.1.1.2, right? Now 12.1 and 12.2 can communicate with each other, both belongs to same subnet, right? So we can run any routing protocol here. We can enable routing protocol, and through which we can exchange all the routes. This is one method. But between distribution layer switch 1 and distribution layer switch 2, we have only one link. If this link will goes down, we don't have any redundancy here. But you can see these switches are connecting, are exchanging lots of routes. If the port will get fail, or link will get fail, or there is congestion, will have issue, will have slowness, congestion, user will get bad experience, right? So you can add one more link here. You can configure that also L3 link, right? For an example, I am connecting 4 links, right? And on all the link I can configure IP address. Here 13.1, 13.1, here 14.1, here 15.1, and on all the links I can configure routing protocol, right? So when you will learn the routing protocol, you will see a router like layer 3 device will generate messages, right, to exchange the route, to form the neighborship. So here on 4 link, if you are going to enable routing protocol, means distribution layer switch is going to generate 4 hello message after every 10 seconds, right? So we will have the issue with CPU utilization. Here we'll have issue with CPU utilization. So this is not sufficient method. So what is the another method here? This is also fine, we can do it, but this is not the best method, right? Second method, you can do one thing. You can add one link here, and you can configure that link as layer 2 link. This is layer 2 link. Then I can configure it as trunk link. Trunk link. I can configure this link as trunk link. Now this link is going to forward L2 traffic, right? And to exchange routes, what we can do, we can create one VLAN here. Let's say VLAN 192, and here I can configure IP 12.1.1.1, and on switch number 2 also I can configure VLAN 190, 192, and I can configure IP 12.1.1.2. Now tell me, can 12.1 ping to 12.1? 2. Can 12.1 ping to 12.2? Yes, because on the trunk link all the VLANs traffics are allowed, so it can ping. It can ping. So again here on VLAN 192 we can run any routing protocol, and again your routing protocol will come up, it will form the neighborship, and it can exchange the route. But again we have what issue? Single link, redundancy, load balancing, not possible, right? So this is also one method. This will also work, and this is commonly used method in the enterprises company, because this scenario, see, in this scenario your link is going to carry L2 traffic as well as L3 traffic. This trunk link is going to carry L2 as well as L3 traffic, right? So let's say this server is in VLAN 10, and here I have one server in VLAN 20, S2, right? So if S1 is going to communicate with S2, they can communicate like this also, right? Or for an example, here I have user in VLAN 10, here I have one user in VLAN 10. So they can communicate through trunk link with the help of .1q header, right? And if this is in VLAN 10 and this is in VLAN 20, then also they can communicate through routing protocol, right? So this time my layer 2 link can carry traffic of both layer L2 and L3, but issue is same: no redundancy, no load balancing, no backup, right? So the third solution is L3 Ether channel. Now in L3 Ether channel, what you will do, you are going to connect multiple link between switches, right? You know how to bundle multiple link, right? Let's say I have 3 links, right? So I am going to first bundle these 3 links together, correct? And I will run no switch port command, right? And then here I have port 1, virtual port 1, here port 2, port 2. Now on this port channel I can configure the IP address. Here I will configure IP 12.1, not on VLAN 192, on P1 and on P2. Then also my routing protocol neighborship will come up here 12.1.1.1 and here 12.1.1.2. right, again these two IP addresses can communicate, and here you can see in this port channel we have 3 link, right, but we'll have only one edge ARP neighborship, one routing protocol neighborship, and until and unless one link will be up between switches, my routing protocol will be working fine. So this is the benefit of using L3 Ether channel here. Clear guys? You should have knowledge about all these 3 methods. Clear? Any question? If it is clear, please tell me so that I can show you the practically also, like how to configure it. After that we'll see L2 security. Is it clear to everyone? Please confirm.
Yes, sir.
Great. Nabil? Vishnu?
Yes, sir. Thank you.
Vishnu, is it clear to you? Sabir? Ajay?
Yes, sir.
Clear to all?
Yes. Yes, sir.
Okay. If anyone have any question, you can unmute yourself and you can ask. Now see how you can do it practically. See, between D switch 1 and D switch 2 I have 2 link. First I am going to bundle it, right? You know, for the Ether channel we have some requirements. May I know the requirements, all requirements of Ether channel? Trunk. I don't have trunk link. What are the requirements
Sir,
of Ether channel?
duplex speed, Ether channel standards,
Duplex should be
trunking,
same.
native VLAN,
Speed should be same.
encapsulation and pruning eligibility must match.
Great. First of all, on D switch 1, I am going to let me create the scenario first.
Here duplex should be
Yes, duplex should be
same.
also same. VLAN
Then
VLAN 10 for
then both should be
correct. Correct.
same on both sides.
Correct. This PC is in VLAN 10 for an example. This PC is in VLAN 20 for an example. And this PC is in VLAN 30 for an example. 20 and 30. 30. Okay. And here also. Right. For VLAN, let's say 10 and 20, we have SVI on switch number 1. D switch 1, we have SVI for VLAN 10 and 20. VLAN 10 and IP address is 192, or let's say 10.1.1.0/24. For VLAN 20, we have SVI 20.1.1.0/24. And on switch number 2, we have SVI for VLAN, let's say on switch number 2 we have SVI for VLAN, let's say 30 and 40. 40, right? The subnet over here is 40.1.1.0 and here is 30.1.1.0, and with the help of L3 Ether channel we need to exchange these routes. So let me configure the scenario. Interface E0/2, E0/2, I'm going to say switch port access VLAN 10. Interface E0/3, switch port access VLAN 20. Exit interface E0/1/0, switch port access VLAN 30. Clear? On here I am going to create SVI also for VLAN 10, say no set and IP address. Let me use last IP address from the subnet 254 as a gateway IP address, correct? Interface VLAN 20, again I am saying no set and IP address. What will be IP here? IP address 20.1.1.254 255.255.255.0. Clear? You can verify it. So IP interface brief done. Interfaces are up. And guys, if your line protocol or status is down, how you will troubleshoot? First you will verify the VLAN database, right? Then there should be at least one interface in that VLAN, or one link must be configured as trunk, otherwise your SVI will be down. Okay, now on switch number 2, config T, interface E0/2, switch port access VLAN 10, exit interface E0/3, switch port access VLAN 20 and exit interface E1/0, switch port access VLAN 30. Then interface VLAN 30, no set and IP address. I'm going to configure 30.1.1.1 last IP address, sorry, 254 and 255.255.255.0. Then interface VLAN 40, say no set and IP address. IP address is 40.1.1.254 255.255.255.0. Now you can verify. Do so IP interface brief. Guys, you can see my SVI 40 is down. May I know the reason?
No interface added.
No interface, the VLAN trunk.
Do so VLAN brief.
Trunk storage.
First of
VLAN
all,
database.
VLAN 40 is not there in the VLAN database. Let me create it. VLAN 40 exit. Now do so IP interface brief. VLAN 40 is there. Do so IP interface. Still this VLAN is
Down.
down. Right. So to up it, what we can do? See, do so IP interface brief, or better to use do so interface status. How many interfaces I am using here? 5. 0/02, 0/3 and 1/0, 1/0 till here. So I am going to configure this link as a trunk link. Interface E1/1, switch port trunk encapsulation.1q and switch port mode trunk. Now I have trunk link, so my SVI should be up. My SVI should be up now. Why SVI is down? Do so interface trunk. Now we have trunk link. Guys, this SVI will come up or not? Will this SVI come up? Interface VLAN 40, no set command is already running. Otherwise, here you will get administrative down. Now you can see the log message. My SVI is up. Clear? Now let's configure L3 ether channel. To configure L3 ether channel, first of all I am going to select the interface range is 0/0 to 1. Set the port and run no switch port command. Right, this command will make these interfaces as layer 3 interface. And now I am saying channel group number, for an example 10, and mode, let me use a static method, mode on. Done. Do show history. I am going to copy these commands and I am going to paste it on switch number 2 also, because we have similar interfaces. Interfaces ID are same. Done. Do show IP interface brief. Done. Down. Now question is how to verify that this is a layer 2 ether channel or layer 3 ether channel. How to verify that? So ether channel summary. Are you able to see any information related to layer? Protocol is null. I'm not using any protocol here.
Yeah, AR is there.
In the S2 MAC upper side, no? In the top.
See
R
this
is
R.
represent as L3.
Very good.
It's down.
Very good. This R is representing layer 3. Right, here you can see
The channel
the
is
R means
down.
layer 3. S means
Layer 2.
layer
Layer
2.
2.
R stands for routing. S stands for switching.
Switching.
Right, now I am going to up the interface so that my ether channel can come up. Say no set here and do so history. Copy the command and let's paste these two commands on switch number 2 also. All good. Now see, so IP interface brief. My port channel is up, but not assigned. IP address is not assigned. Now it is layer 3 ether channel, so we have to configure IP address now. Clear, guys? Even multiple verification commands are there. So ether channel summary. Here also we can see the R. Then we can use detail command here. Ether channel detail. Right, here also we can check the state. Group state is L3, correct? Right, so now here we have the port channel name is 10 P10, where I am going to configure IP 12.1.1.1 for an example. Any IP you can configure. And on switch number 2 I am going to configure 12.2. Clear? Go to switch 1 and config T. Sorry, till then let me configure switch 2 interface. And what is the name of my port channel? Do so IP interface brief P10. Right, so interface P10 and IP address. If it is layer 2 ether channel, then you will be not able to run this command IP address. Right, it is layer 3, so I am able to run this command. 0. Done. Now do so IP interface brief. You can see the interface is assigned IP address. Then switch 1 config T interface P10 and IP address 12.1.1 255.255.255.0. correct? So IP interface brief. Done. And let me ping switch number 2 now. Ping 12.1.1.2. You can see ping will work. Ping is working. Now I can configure any routing protocol here. In configure, like on switch number 3, if I am going to configure a IP here, IP 10.1.1/24 and gateway is 254. On PC number 4, I am going to configure 20. IP 20.1.1.1/24 and 20.1.1.254. PC5. IP 30.1.1/24 and 30.1.1.254. Question is, can PC3 ping to PC5, guys? Can PC1 ping to PC5? Okay, can PC3 ping to PC4? Can 10.1 ping to 20.1?
Yes.
Yes, sir.
Yes, yeah.
Can PC3 ping
Because
to
of
PC5?
Routing is not enabled now.
No.
no.
No? Then where packet will get dropped? On which device? Check packet flow.
On the switch.
On which switch? Switch 1 or switch 2?
Switch 1.
Switch 1. All are saying switch 1. Yes. See on switch number 1. So IP route. Guys, here we have 10 subnet, 12 subnet and 20 subnet. This switch cannot forward traffic for 30 subnet, right? PC5 IP 30.1. So switch 1 is going to drop the traffic. Right? Okay, can PC3 ping to PC6? Can PC1 or PC3 ping to PC6?
No.
Yes, no brother, both belongs to VLAN 10.
Same Mila.
No, answer is no. And where traffic will get dropped?
Switch 2.
Switch 2, because switch 2 don't have route. So see, I am able to ping 20.1 from PC number 1, PC number 3. But I cannot ping 30.1. 30.1. You can see destination host unreachable. Means my default gateway don't have route. Right? So let's configure the routing here. We can enable any routing protocol, and later you will learn the routing protocol. Router AGRPS number 10 I am saying, and network 0.0.0.255. Ignore it. Okay, AGRP is enabled, and on switch number 2 also. Now you can see we have AGRP neighborship here. Guys, on which interface we have AGRP neighborship? So
Port channel.
AGRP neighbor on the port channel. So if any link will goes down, will it affect AGRP? No.
No.
And so IP route AGRP. Now you can see I am learning 30 and 40 subnet, and on switch number 2 we'll have 10 and 20. So IP route AGRP. So now routing table is centralized. So IP route. Now all the routes are there in the routing table, right? So now PC3 can ping, like all the PCs can communicate. Now you can see. Why ping is not working? What happened? 30.1. See, if I am getting destination host unreachable error, that means my default gateway don't have route. But this time I am getting what? Request timeout error. That means there is some issue with reply packet. Right? So why I am not getting reply? See, here on PC number 3 we have IP 10.1 and here IP 30.1. Right? So if I am going to ping 30.1 from 10.1, source IP 10.1, destination IP 30.1, it will forward to switch. Switch is going to check the routing table. In the routing table of switch 1 we have route. It will check routing table like this. So IP route and destination IP 30.1.1.1. It will say okay, 30 network is reachable via 12.2, and to forward traffic to 12.2 exit interface is port channel 10, right? So it will forward traffic through port channel. In the port channel we have two interface. You already know how to select the physical interface. It will forward traffic to switch number 2. On switch number 2 it will check destination IP, so IP route 30 network is available on which interface? On VLAN 30 interface. On VLAN 30 interface, 30 subnet. So now can anyone tell me why ping is not working? See, from PC number 3, if I will ping 30.2, which is PC8, 30.2 PC8. Again, ping is
You type 30.3.
30.3, 30.2. I am getting reply message. Ping is working. 30.1 is not working. Let me verify once IP address here. 30.1 gateway IP address is 254. From PC5 I am going to ping gateway 30.1.1.254. Even I am not able to ping gateway IP address from PC number 5. So for the troubleshooting, so IP interface brief, here IP address is correct. IP address over here is correct. Ping should work then. Then ping should work. .1.1.1 this ping is not working and I am getting unreachable error here, not reachable. Network is directly connected over here, so it will not route the traffic. What can I do here? So what will happen, guys, in the production network, whatever SVIs you have here on this switch number 1, you will have user in these VLANs only over here. Like here I have SBI user in VLAN 10 and 20, so I will have SBI for VLAN 10 and 20 on this switch, right? On this switch I have user in VLAN 30 and 40, so I will have SBI for VLAN 30 and 40 on this switch, right? After that we will be exchanging those routes through routing protocol, right? And then ping will work. Like you can see VLAN 10 user and 20 are able to communicate. Even VLAN 20 or 10 are able to communicate with VLAN 30. Like from PC number 3 I can ping to PC number 8, but I cannot ping to PC number 5 because PC 5 is connected with switch number 1 where I don't have any SPI for VLAN 30. PC 3 and ping 30.1.1.2. This ping will work. You can see this ping is working. So here I have to correct it, like I have to place this PC in VLAN either 10 or 20, not in 30. Okay, clear? This is
Sir, in this way, it will not communicate. What is the reason why it is not sending the traffic there?
see now brother, when you are pinging 30.1 like on distribution layer switch 2, 30 network is directly connected, so it will not route the traffic back to switch 1 na. Like if I am pinging 30.1 from PC number 3, 30.1, this switch is going to check routing table, it will forward traffic to switch number 2. Switch number 2 will not forward traffic back to switch number 1 because VLAN 30 is directly connected on this switch, right? So whatever interfaces are there in VLAN 30, it will forward traffic to those interfaces, from those interfaces only. This is the reason. Switch 2 will drop the traffic. Switch 2 will not find any user in VLAN 30 who is using this IP address 30.1.
Sir, can we check this through traceroute command? Is it possible so that we can see
Yes,
where
you
the
can.
traffic is being dropped?
Yes, you can. You can trace route. Trace and 30.1.1.1. You can see traffic is going to switch 1. This is the IP address of switch 1. Then switch 1 is forwarding to 12.2, switch 2, and after that we are not able to discover the hop. Okay. Okay, brother.
But sir, we already enabled the ARP, no? Directly
Yeah, but
connected network from switch 2, it will forward to switch 1 also.
which one? Switch 2. No, see brother, what
Yes,
is
switch
happening
to
here
routing table.
on switch number 1, you have connected network 10 and 20. This one and this one, right? Why
Yes,
you will have user in
yes.
VLAN 30 here? You will not have user in VLAN 30 over here now. VLAN 30 means 30 subnet is connected on switch number 2. So you are saying like when this user and this user will ping, it should forward traffic to switch 1, should forward to switch 2, and then switch 2 should again forward it to switch 1. Again switch 1 will forward it to then switch 2 also only, because we have 30 networks in the routing table towards switch number 2.
Yes, sir.
Right, so this switch will always route traffic for 30 subnet to switch number 2 only, correct? This is the issue here. Or we can add one L2 link here, right? We can configure one link as trunk link, then also it will work. Then what will happen? Then see, when switch 1 will forward traffic to switch number 2, switch number 3 is going to forward one copy from the trunk link, right? And switch 1 will receive it, switch 1 will check tag value is 30, on the basis of that it will forward traffic from this port, right? So one L2 link we can add here. So remember the first scenario here, where what I told you, if we have one link we can configure that link as trunk, and we can forward L2 and L3 traffic from this link, right? So that is the what I told you, that is the most commonly used scenario in the enterprises company. This is the reason. Clear, guys?
Sir, can we ping PC6 to PC3, VLAN
PC,
10?
yes, you can.
Can we try? It shouldn't
Again,
work, no,
no,
sir.
both in VLAN 10, na? VLAN 10 should be here on switch number 1. Again, it will not work. Same issue.
Can we just try, sir?
PC3. PC3 is in VLAN 10. Ping IP 10.1.1.2. Got it?
Okay, sir. Yeah. Thank you.
Now, guys, we have some security features. So, how many of you have remembered the DHCP? DHCP.
DORA process.
DHCP works on DORA process. Now, for an example, I have a scenario like this. Switch 1, have some user, okay, and here is my DHCP server, let's say router, right? Maybe this is DHCP server or this is relay agent. Relay agent means maybe my DHCP server is in remote location, in remote network, right? Then my router will be relay agent. R1, maybe this is my DHCP server or this is relay agent. PC1, PC2 and PC3, right? Okay, and this router is connected with internet, right? And in the remote side I have DHCP server, so my router is working as a relay agent. Okay, now what will happen when user will try to get IP address from the DHCP server? DHCP, it will generate discover message, and discover message is broadcast, right? Guys, what if the attacker is going to provide IP address to the client machine? If your actual DHCP server is at remote location and attacker is connected in your network, here is the attacker for an example, right? Then definitely your PC will receive offer message from the attacker first, right? PC will get two offer message, one from the attacker and one from the actual DHCP server, right? Which offer message PC will accept? PC don't know who is attacker, who is the offer message of attacker and who is the offer message of actual DHCP server. It will accept the first offer message, right? If attacker will send offer message first, then PC is going to use that IP address, right? So let's say in the DHCP server I have created one pool with name Cisco, where my network is 10.1.1.0 and mask is 255.255.255.0 and default router means default gateway is 10.1.1.100. This is the actual DHCP server, and this attacker rogue DHCP server have also created one pool, right? But their gateway IP address is different. Let's say 10.1.1.200 is the gateway, 200, right? Network is same 10.1.1.0, 255.255.255.0 and pool is fake. Got it? Right? And let's say this attacker system laptop is connected to again internet through dongle, through Wi-Fi. The attacker is also connected to internet, Now see the issue. Right now guys, PC need IP address, so PC will generate discover message. It will forward to switch, and the switch will check the destination MAC. Destination MAC is broadcast. It will forward one copy to the router, right, and one copy to attacker, right. If router 1 is DHCP, genuine DHCP server, it might be possible that PC can get offer message from the genuine DHCP server first. But if DHCP server is in a remote location and router is a relay agent, then definitely attacker offer message will be received first by PC. Correct? So both DHCP is generating discover message. What if PC will get offer message of attacker first? Right? If this is offer message, if PC will get attacker offer message, then PC is going to configure what default gateway. Let's say IP is 10.1.1 and default gateway is 10.1.1.200. Now whatever traffic PC will generate for internet, let's say for 8.8.8.8, right, it will forward to switch, and switch will forward to attacker, and through attacker PC can reach to internet, can access internet. But here attacker can use any sniping capturing tool. They can capture the traffic, they can intercept the traffic, they can modify the traffic. Let's say this user is transferring $100 to their friend, 100 USD dollars to their friend, right? Now attacker can change the price, they can change the destination, they can inspect the traffic, they can see everything. Whatever username and password you are going to put to login in your bank, attacker can see that, right? So this is one kind of attack, DHCP attack, right? This attack is called DHCP spoofing. Guys, there are two terms, DHCP spoofing and DHCP snooping. May I know the difference between spoofing and snooping? Spoofing means something called attack, and snooping means
You protect the interfaces.
yes,
with
protecting this attack, right? So this type of attack is called DHCP snooping, and protecting it is called DHCP snooping. So what we'll do, we'll enable DHCP snooping on the switch. We can enable DHCP snooping on the switch. Anyone have idea about it, how it works?
You configure the interfaces as trust and
Okay, see, by default all the interfaces are trusted, but once you will enable the DHCP snooping on the switch, all the port will become untrust, and on untrust port, switch can never receive, can accept offer message, any message generated by DHCP server. See, in the DORA we have 4 types of messages. Tell me which messages will be generated by client machine?
Discover.
Discover request.
Discover and
Requests.
request. And by server?
Sir, as offer and acknowledge.
Offer and acknowledgement, right? So offer and acknowledgement cannot be accepted by switch on the untrusted port.
Yes.
On the untrusted port. So what I can do, see, all the uplink port will be configured as trusted. Like this port is going to be trusted port only. I will configure this port as trusted port. Trust. So you can trust on this port only. Right now again PC will generate discover message, it will forward to switch, switch will forward to attacker as well as a router, Again attacker is going to generate offer message, but this time switch is going to receive offer message on untrusted port, so it will decline it, it will discard it, right? On untrusted port it cannot accept DHCP server message, right? If I will talk about DHCP client, so client is going to send discover and request message, request. And if I will talk about the server, so server is going to send offer and acknowledgement. Got it? Is it clear? And guys, one
Yes,
thing,
sir.
tell me one thing, like whenever a DHCP server is going to provide IP address to client, what is lease time? Like for how long time it is providing the IP address?
Default 24 hours, sir.
Yeah, that is lease duration, 24-hour by default. By default,
24 hours.
24 hour. And after 50% of interval, like after 6 hours, switch is going to send renewal message. Like sorry, not switch, client machine.
Client,
Whenever server, DHCP server, CP server provide IP address from the pool, right? And we can reserve the IP address, we can exclude the IP address as well, right? DHCP server maintain a table called binding table, right? And the leased duration is equals 24 hours, 24 hours, right? Minimum interval you can configure is 1 minute. Minimum interval can be 1 minute, and maximum interval can be 999 days, 23 hours and 59 minutes and 59 seconds. This can be the maximum, right? And always keep in mind, after 50 hour of 50% of time, after 50% of lease time, after 50% of lease time, client machine is going to send renewal message. Client machine will send renewal message, right, for the same IP address, like please renew the IP address. And whenever client will send renewal message, there are two chances. One, DHCP server is reachable or DHCP server is not reachable. If DHCP is reachable, then DHCP server is going to renew the IP address. Again timer will set to 24 hour. Again after 50% of time, same thing will happen. But if DHCP server is not reachable, then again after 87.5% of time, right, means 25% time. After 25% means total 75.5% of time, client is going to send renewal message. Again, if there is connectivity, then DHCP server will renew the IP address. If there is no connectivity, then again after 3 hours, when 3 hours is left, DHCP server is going to send renewal message, right? This way DHCP is working. And if DHCP server is still not available, then after 24 hours, client machine will get IP address from APIPA. APIPA. What is APIPA? After 100% of time, after 100% of time, client will get IP from APIPA server. What is APIPA server? No idea.
It is a range of IP address one.
Yes, sir.
APIPA
169.
stands for what?
Automatic IP private addressing.
Private IP addressing, right? Range of APIPA is 169.254.0.1 to 169.254.255.254. This is the range of APIPA, I think. Yeah, this is the range only. We can check it once. Correct. This is the range of APIPA IP address. Right. So this is, guys, the IP address provided by APIPA server, and on the every client machine, APIPA is configured. It work similar like DHCP server. Right. As you know, to communicate with network, client need IP address, right? So if DHCP server is not reachable, whenever DHCP server is not reachable, client will get IP address from APIPA only, right? Just to avoid the unwanted broadcast, right? Otherwise, see, if client is not able to get IP address from DHCP server, then it will be keep generating discover message, which is the broadcast. It can increase the flooding, broadcast flooding in the network. Right, so to avoid that flooding only, we have APIPA concept. Clear? So this is main concept of DHCP. Okay, so on all the switches, if DHCP is enabled, what you will configure? DHCP Snooping. Okay, any question here till here?
Yes.
Clear? All clear? It is a security feature on switch. DHCP Snooping is a security feature of switch that is used to filter DHCP. Which message? DHCP offer an acknowledgement message on the switch. And DHCP Snooping will only filter DHCP message. It will not filter the user data. Right, for user data, for rest all types of traffic like L2 protocol, L3 protocol, or user data, it will not work. It will not filter any other traffic. Right, so all your uplink port should be configured as trusted port. Here I have only one switch, right, but in the real time you will have design like this. You will have design like this. What happened here? You will have access layer switches and then distribution layer switches. Right, and in most of the cases you will have DHCP at remote location, in the DC, in the headquarter, like that. So all the uplink port. And here we have users. We can enable, we can make trusted port to port channel as well. Here I have users. Right, so see, uplink port means what? Downlink port means these ports. These ports are downlink port which are connected with users, and these ports are uplink port. So here on these uplink ports, DHCP snooping should be enabled, right? On distribution layer switches, here we have, for an example, router, right? So again, these two ports are uplink port, right? And these ports are downlink port. So these ports will be untrusted and these two ports will be my trusted port. Hope it's clear now. So whenever client will generate discover message of DHCP, access layer switches are going to forward it to distribution layer switches. Distribution layer switches are going to forward it to router. And when router will generate offer message, switches are going to receive it on uplink port only, right? So on all the uplink port will enable, like will configure trusted port. Configure as a trusted port, right? And after the DHCP snooping, once will enable the DHCP snooping, what switch will do? Switch will inspect the traffic. Switch will inspect the traffic. For an example, if this client machine have generated the discover message, right? So switch is going to receive it on this interface. If DHCP snooping is enabled, then switch is going to inspect the traffic. Inspect the traffic means it is going to check the traffic, right? If it is okay, then it will forward, otherwise it will discard. Inspection means traffic check. It is going to perform checks. Check. And after check, we have two conditions, either okay or not okay. If okay, then forward. If not okay, okay, then forward. And if not okay, then not okay, then discard. Discard. Now you might be thinking, Praful, how switch is going to inspect the traffic? Don't worry. Clear? If it is normal traffic, then okay, switch will accept it, forward it. If it is not okay, it will discard it. This type of attack is called DHCP based attack. Sometimes we are saying DHCP starvation. In the exam, you can find this word, DHCP starvation, right? DHCP based attack. And you know, like the attacker can spoof the MAC address, right? Their MAC address. A spoofed MAC address, that is called a spoofed MAC address. And similar way, we have one another type of attack that is called ARP inspection attack. Like for the ARP request message, like when user will generate ARP request for, let's say, 10.2, right? So attacker can send their own MAC address instead of MAC address of 10.2. So again, when user will try to reach internet, it will reach through attacker device. Whenever client will try to communicate with 10.2, it will communicate to attacker. Right? Or one more type of attack can be happened here. Let's say, for an example, this is my DHCP server, guys. This is my DHCP server, and in the pool total IP addresses are 254. 254 IP addresses are available in the pool for the clients. We have around 200 clients, and if there is attacker, if this attacker is going to send lots of discover message by spoofing the MAC address from the multiple MAC address, let's say from source MAC A, it have sent the discover message, right? Source MAC B, like this. If it is going to send 254 discover message with a spoofed MAC address, then what will happen? Your DHCP pool will get full, yes or no? Then when actual client will generate request for the IP address, DHCP server cannot provide IP because there is no IP address available. Because IP address is not available in the pool. Pool is full. Right? So this way also attacker can attack, can fool your DHCP pool. Right? It will target the DHCP pool by spoofing the MAC address. This particular types of attack is called denial of service. Right? Like this is in TCP also. Like let's say you have one server where you are running HTTPS service. HTTPS service domain name, right? So attacker and this server have some capability to, let's say, establish 200 connection at a time, right? So if attacker is going to send 200 SYN messages with a spoofed address, then what will happen again? All the TCP ports will occupied. So actual user cannot access the website. Right? Like when you are downloading your result guide, you might have seen these types of issues. When lots of users are trying to access the application at the same time, your TCP ports can get full. So this is also one kind of attack. This is called DOS attack. Denial of service attack. Right? And if you will check DHCP message, you will get one more field there, that is called CHADDR field, right, for the MAC address. Like in case of relay agent, for an example, this router is relay agent, right? So guys, when client will generate discover message, source MAC will be the MAC address of client. But when router will forward the discover message to actual DHCP server, which is at remote location, so every time source MAC is going to be what? The MAC address of relay agent, router. Right? So that's why we have this field in DHCP to carry the actual MAC address of client in the discover message. I don't know what is the pronunciation of this word. We can say CHADDR. Right? It will carry actual client hardware address. It indicates the MAC address of client in the discover message. So attacker can spoof this address also. Attacker can spoof this address also, and that is also one kind of DHCP attack. So these are the attack can be performed in the network through DHCP. To avoid it, we can enable DHCP snooping. Man in middle attack also. We can say man in middle attack also. When you will learn the DHCP in detail, now you will get two more types of messages in DHCP. Like by the server, you know, two messages. DHCP server sent two messages, offer message and acknowledgement, offer and add.
Acknowledge.
And later you will learn NAC also. NAC. This is opposite of acknowledgement, used to decline the client request. It is used to decline the client request. And by the client, you know, discover message, request message, and you also know one release message, right? Like to tell DHCP server that the client is no longer need this IP address, right? We have one release message. By the client, you know, discover message, you know, request message, you know release message. Release message, how many of you know about the release message, guys? It is used to tell the DHCP server that client no need IP address now. Like you can say used to terminate the IP address, right? And later you are going to learn one more types of message by client, that is called decline message. Decline message used to decline the IP address offered by DHCP server. These are also the concept of DHCP only, right? So this is not the end of DHCP here. This is sufficient for CCNA and CCNP. Okay, so let's see how we can configure this snooping. Here I will have
Sir, excuse me. I have a question here. Suppose the old topology, this topology, if we configure default route on both sides, can it solve the issue? I'm not talking about DHCP and all this. I'm talking about the previous scenario, the one which did not work.
okay. Here in
So
this
if we
topology,
configure, no, the previous one, sir, where we were discussing port
this
channels
one,
L3.
Uh,
Yes. So
layer 3 port. Yes, yes.
yes, if we put default route on both
Yes,
sides,
just change the
0.0,
default route.
will it work?
no, it
I
will
think
not
it
work.
should
See,
work.
when default route will work, when a specific route is not available, right? But 30 subnet is already there, so it will not use default route for 30, right? Leave it for the routing. Okay, in the routing domain you will get it in detail. Default route will also not work here, right? Simply what I told you, will not have 30 VLAN 30 users here on switch number 1, and will not have VLAN 10 users on switch number 2. If we have VLAN 30 user on switch number 1 and VLAN 10 user on switch number 2, then I need L2 link here, trunk link. Okay, you can add one more link, you can configure that as trunk, and after that you can check these PCs are able to communicate or not.
So, sir, this means in this way we can we say that your SVI can exist only in your L2 domain?
No, how you can say that?
Because in VLAN 30 the SVI was it was not on the same L2 domain. It was segregated by an L3 link.
Wait brother, 1 minute, telling you that. Mm, mm. Yeah, okay, this topology is, yeah. Yes brother, tell me now. See what I am saying here, I have users in VLAN 10 and VLAN 20 and VLAN 30. but SVI interface for VLAN 30 is on switch number 2. Correct? SVI for VLAN 30 is on switch number 2. So switch number 2 is not going to forward traffic for VLAN 30 to switch number 1 na, because VLAN 30 is directly connected, like 30 subnet is directly connected on switch number 2. So if there is trunk link, then it can forward traffic for all the VLAN through trunk link.
Yes.
This is the reason why it is not able to ping, why it is not able to forward VLAN 30 traffic. But this is L3 link, you can say L3 link.
So this is what I was saying, that my SVI can only exist in my L2 domain. It cannot be separated by an L3 link.
Your SVI can be, yes, you can say,
Only in
yeah,
your
correct.
L2 domain.
Correct. You can see that. Here I am going to add one more DHCP server, that is attacker DHCP server. Or why I will add attacker server, you guys can understand it. See, on router I am going to enable DHCP service. I have 2 VLAN. I am going to create 2 DHCP pool here. No. Enable config T. Tell me how I can configure the pool. First of all, I am going to create 2 SVI here for both VLAN. Encapsulation.1q for VLAN 10 and IP address 10.1.1.254.255.255.255.0. Exit, this is router on a stick, nothing else. 20.
Sir, you are in the sub interfaces, sir. You are not created in the sub interfaces for the 10.
I am creating sub interface only, na?
Just the first interface.
I am dividing 0/0 into 2 interface, 2 logical interface, so that VLAN 10 and 20 user can communicate. Then I am creating DHCP pool, IP DHCP pool, and let's name it to VLAN 10. And here I am going to use network 10.1.1.0 and 255.255.255.0. Then default router I am going to say 10.1.1.254, and DNS server let's say 8.8.8.8. Exit, IP DHCP pool and say VLAN 20 and network 20.1.1.0 255.255.255.0. default router is 254 and DNS server let's say 1.1.1 for VLAN 20 user. Okay, done. Clear guys? I have created 2 pool so that client machine can get IP address. On switch, let me configure this link as trunk link and let me put PCs in VLAN. Config T, interface E0/0 switch port access VLAN 10. Exit, interface E0/1 switch port access VLAN 20. Interface E0/2 switch port trunk encapsulation.1q and switch port mode let's say dynamic desirable. On switch number 2, interface E0/0 switch port access VLAN 10. Exit, interface interface E0/1 switch port access VLAN 20 and do so interface trunk. So we have trunk link. Good. Can PC1 get IP address from the DHCP server? Yes. IP DHCP. Why PC is not able to get IP, guys? This link is not configured as trunk 0/3. Let me configure it. Interface is 0/3 and say switch port trunk encapsulation .1q and switch port mode trunk. Done. Let me disable the spanning tree protocol also, otherwise it will take 30 seconds. For VLAN 10 and 20 I'm going to disable the STP. No spanning tree for VLAN 10 and no spanning tree for VLAN 20. Now PC1 IP DHCP. This time what will happen, switch 1 is going to send discover message from their all interfaces. Switch 1 is going to send DHCP discover message from all the interface. It will receive over here, it will forward from this interface. Right. So I am going to make this interface as untrusted, all the interfaces as untrusted except this interface. See, the PC got the IP address 10.1 and on the DHCP server we can check the binding table. So IP DHCP binding. Here you can see with the help of MAC address there is one entry. This is the MAC address of PC1 and this is the IP address assigned to PC1. Right, method, state, everything is there, all the information. On the switch 1, so IP DHCP snooping. By default you can see snooping is enable or disable. Disable. By default it is disable. So first of all let me enable it, and you can see there is no any trusted port, means all the ports are untrusted, right? But once you will enable the snooping, after that all ports will become untrusted, right? To enable it, simply say IP DHCP snooping, right? First we need to enable it globally and after that we need to enable it for the VLAN, right? So IP DHCP snooping for VLAN 10 and for VLAN 20 also, right? Now can PC1 get IP address? Now PC1 cannot get IP address from the DHCP server, I think. IP DHCP. Now you can see it is not able to.
No trusted port.
Sorry?
Because there is no trusted port.
Yeah,
There
there is
should
no
be some
trusted port and PC is not able to perform now DORA process, DORA operation. So let me take you to switch, and here I am saying interface E0/3 and IP DHCP snooping trust, right? Now so IP DHCP snooping. Now you can see this port is trusted port 0/3, okay, and DHCP snooping is now enabled. Now can PC get IP address from the DHCP server? Yes. What happened? What happened? Debug IP DHCP server events. Even router is not receiving DHCP discover message. On the router we are not able to see any discover message. So IP DHCP binding, clear IP DHCP binding star. Now there is nothing. DORA process is not working. Let me try for VLAN 20. IP DHCP. VLAN 20 users are also not able to get IP. So IP DHCP pool is fine. That means there is some issue on switch only.
Parafo should be configured also for the both VLANs.
Yes. Wait a minute. What is the issue? So IP DHCP snooping. Switch DHCP snooping is enabled. Switch DHCP. Okay. DHCP snooping is configured on the flowing VLAN 10 and 20. DHCP snooping is operational for flowing VLAN. Okay. DHCP snooping is configured on the flowing L3 interface. Okay. Insertion of option. Okay, so whenever you will enable DHCP snooping on the switch, automatically it will enable option 82. Option 82 is for relay agent, right? My switch is not relay agent, correct guys? So we need to disable it. Let me say no IP DHCP, no IP DHCP snooping and information option. I am going to remove this command. Automatically it will add this command. Just remove it and then you can try. Where is the router? Here. And on the router debugging is enabled. Now let me take you to PC1 and say IP DHCP. Now you can see here I am able to see the operation on router, right, and it is able to perform the DORA process. Now PC got the IP address. PC2 can also get IP address from the DHCP server now. Yeah, you can see. Okay, done. Now tell me, can PC3 get IP address, guys? Can PC3 get IP address from DHCP? IP DHCP.
Yes, sir.
Yes.
No.
No, because here on switch number 1 0/2 is also what?
It's untrusted.
So
It's for receiving
on
only.
the untrusted port it will not receive any message from the DHCP server, but
it has already received, I think.
Sorry, yeah, got the IP address because it is transmitting a DHCP server message like the offer message. And on switch number 2 I have not enabled the snooping. On switch number 2 I have not enabled the snooping. So once I will enable the DHCP snooping, after that it cannot get IP DHCP snooping and IP DHCP snooping for VLAN 10 and for VLAN 20. Now client machine cannot get IP. PC3
Option also need to disable.
Yeah. Now on switch number 2 we need to configure first what? Trusted port. Which port will be the trusted port here?
0/2.
02.
No to this and interface is 0/2 IP DHCP snooping trust. Right? Now can client get IP? Yes. Done. Clear guys? And PC4 also, PC4 can also get IP DHCP. So in the real-time network you will be always enabling DHCP snooping feature on all the switches. On all the switches. Done. You can see, and now it can communicate. PC1 ping 20.1.1.1 able to ping 10.1.1.2 working, ping 10.3 and 20.2 working. And on switches you can check the binding table. After enabling a snooping switch will also start maintaining a table. So IP DHCP snooping binding table, right? See the IP addresses with MAC addresses, right? So with the help of this table we can configure ARP inspection as well. Okay, all
What is
information.
least time here? Least seconds here?
Sorry,
What is least seconds?
least time.
Yes.
Least time, brother. Whenever DHCP server is going to provide IP address, what I told you, it will provide for 24 hours.
Yeah, that could be in the router only, no? But switch also maintain least
Switch
time?
is also maintaining same table now.
Okay.
After enabling a snooping on switches, which will start maintaining this table. And guys, now we can avoid the ARP inspection attack also, right? The ARP inspection attack means like when, let's say, this PC 20.1.1.1 and here IP is 20.1.1.2, want to 20.1 want to send some data to 20.2, right? It need MAC address table of 20.2, it will check ARP table. If MAC address is no tablable, it will generate ARP request. ARP request. In the ARP request, source MAC will be the MAC address of PC2, destination MAC will be OLAF. It will forward to switch, which will forward from the trunk link. Let's say there is attacker. So this attacker can send their own MAC address. Let's say MAC address over here is B, here A, and attacker is C. So attacker can say IP address 20.1.1.2 and MAC address is C. It will forward to switch, switch will forward to this switch. It will now PC2 will forward traffic to whom? To the attacker. To the attacker. And this is called dynamic ARP inspection. How we can avoid this?
So do you have any trusted port for the cross-checking?
How we can avoid this? See guys, what will happen? Now difference in the ARP reply message of actual device and the attacker is what? IP address with MAC address, right? In the ARP reply of PC4, the genuine PC, destination IP 20.1.1.2 and MAC address is B. And in the ARP reply message of attacker, IP address is same but MAC address is different. Right? So when you will enable the ARP inspection, switch is going to compare it with their binding table, right? So that's why to enable ARP inspection, IP DHCP snooping must be enabled, right? And it will compare whenever switch will receive ARP reply message, it will compare destination IP address and destination MAC address. And in the binding table, guys, we have entry that 20.1.1.1 MAC address is B, not C. Right? So when it will switch will receive ARP reply message from the attacker, it is going to discard it. It is going to check this table. In this table you can see the 20.2 MAC address is this one. Note the attacker MAC address. So this way we can avoid the dynamic ARP inspection attack as well. Clear? So logic is very simple. Switch is going to compare source MAC and source IP address with their snooping binding table. If IP address and MAC address will match, then it will accept, otherwise it will discard. Otherwise it will discard. Right? And ARP inspection is used to secure the ARP reply message. Right? And to enable ARP dynamic ARP inspection, DHCP snooping must be enabled on the switch. Because with the help of a snooping table only, switch is going to avoid this attack. Right? And command is very simple to enable it. Config T, we can say IP ARP and then inspection. ARP inspection. For which VLAN you want to enable? For VLAN 10, for VLAN 20. Right? On switch number 2 also we can run this command. Okay, and again we have to set trust port. Right? So interface is 0/2 IP ARP inspection trust, this command. Right? So now we can copy, do so history, and we can paste these commands on switch number 2 also, from here to here. Clear? On which interface I run trust command? Yeah, perfect. Now one more thing is there, that is, see, till now we have seen DHCP snooping, and dynamic ARP inspection, and one more thing is there, that is called IP source guard. Source guard. This feature is used to bind IP address with interface. IP address with interface. Like you know, on 0/0 interface you have one server whose IP address is 10.1.1.1. Right? So I don't want to allow any other IP address on this particular port. So I can bind this IP address on this particular port with the help of IP source guard. It is used to bind IP address on the interface of switch. IP address with MAC address, you can say. IP address with MAC address on the interface of switch. These all are the security feature. On switch 1, here we can run one command, that is IP source binding, right? And then MAC address. So MAC address of PC1. So IP all. This is the MAC address of PC1. Let me copy it and let me paste it on switch. And then it is asking for the VLAN. So this interface is in VLAN 10. And then IP address 10.1.1.1. What is the IP on PC? 10.2. So let me bind 10.2. 10.2. Then interface. Interface. On which interface? Interface Ethernet and 0/0. Right? Anything else? No. Clear. So see the command do so history. Do so history. This is the command. This is the command. To verify it and to apply it on the interface, we have to run one more command on interface E 0/0 IP verify source. Right now it will always verify the source. Whenever it will receive traffic on this particular interface, it is going to verify the source. Source MAC and source IP, it should be same. Right now let me do one thing. On the PC ping 10.1.1.3, I am able to ping PC2, PC1 to PC2. What is the IP on PC2? PC2, sorry, PC3, 10.3. Why I am not able to ping 10.3? What happened? IP DHCP (10.2) ping 10.1.1.254. Why I'm not able to ping the gateway IP address? I did some mistake here, I think. Then on switch 1, VLAN 10 10.2 interface 0 slash, it's correct. Even from PC number 3 also I am not able to. So IP interface brief. What happened on router? IP is not there. So IP DHCP pool.
There was an error message if you go up in the logs.
Where? On switch?
Yes, switch 1. Look, invalid ARP resolution like this, zoom 0/3.
DHCP Snooping and deny invalid ARP on interface 0/3. Configuration is correct. why it is not storing the IP address of PC1. We did some mistake in the configuration, maybe. IP ARP inspection for VLAN ten. So run interface C0/0s and so run section ARP. Okay, we will see it. What is the issue? Here I think we did some mistake in the configuration, like on the interfaces. Okay, you can try it. You can also try it. Write the all configuration on switch. I think it should work. It should work because this is the only concept. And one more thing is there in the security part, that is VLAN hopping. VLAN hopping. So what is VLAN hopping? VLAN hopping is used to perform tagging on the trunk link. Because guys, again, see, if the attacker knows native VLAN, the native VLAN is 10. So they can attack in your network with the help of native VLAN. So sometime you need to add tag for the native VLAN also. Right? And to perform tagging for native VLAN, we have VLAN hopping. Okay. And then finally port security. Port security and switch port protection. So we'll see these 2-3 types of protection on switches in next class, in tomorrow class. Okay. And I will verify this also, why I am getting error here. Okay. So these are security features on switches. Okay. Anyone can ask you these questions sometime in interview also, in the exam also, right? So just configure it by yourself once. Even you can, I think, run these commands in PKT also, in packet tracer also. And after that we are done with the switching. So only 3 topics I need to cover in next class, and then we have FHRP, first hop redundancy protocol. Okay. Okay guys, any question?
I need to ask sir a question. Is there any command that can show us the link usage, how much the link is being